Here's my Arduino code. The Arduino is set up with two analog inputs, one of them being a reading of the potentiometer and the other being a reading from a signal passed by the Nscope. Depending on the rotation of the potentiometer, it will create a sampling frequency for the Arduino. This Arduino will then sample the signal from the Nscope at that frequency. It'll create a graph like this. Here are the plots for a frequency of 75 Hz. The only sampling frequencies that produced an aliasing frequency was 142 Hz and 100 Hz. For 142, it aliased at 67, and for 100, it aliased at 25 Hz. Here's the plots for a frequency of 100 Hz. It only aliased for a sampling frequency of 142 or 100 Hz, but it was on the cusp of aliasing for 200 Hz. For 142 Hz, it aliased at 42, and for 100 Hz, it aliased at 0 Hz. Here's the plots for a frequency of 215 Hz. It aliased at every sampling frequency except for 500 Hz. For a frequency of 200 Hz, it aliased as 15. For 142 Hz, it aliased as 69. And for 100 Hz, it aliased as 15. Here's the frequency of 300 Hz, which aliased for every sampling frequency that was tested. For 500 Hz, it aliased as 200. For sampling frequency of 200 Hz, it aliased as 100. For 142 Hz, it aliased as 16. And for 100 Hz, it aliased as 0. To calculate the aliasing frequency, I first found the Nyquist frequency, which is half of the sampling rate. I then created this folding diagram where you can locate the frequency of the signal on the graph, and then fold it down and find what the frequency would alias as. By knowing the sampling frequency, I could calculate the theoretical aliasing frequency. And by getting data from the graphs, I could find the experimental aliasing frequency. I was then able to fill in this chart full of data. One interesting thing that I noticed is that when there was a difference between the experimental and theoretical aliasing frequency, the experimental frequency tended to be lower. Here I have the Nscope generating a 10 Hz square wave. And this is how it appears on the oscilloscope and the frequency spectrum plot. Now I have the Nscope generating a triangle wave, and this is how it appears on the time plot and the spectrum plot. One thing that you can notice from the square wave is that though it doesn't look curved, the frequency plot actually shows that it's a sum of multiple sinusoids with varying frequencies that act as harmonics to each other. The same thing can be seen for the triangle waves. Though there might not be as many harmonics, there is still multiple sinusoids adding up to create the triangle.